Hi guys, my name's Chris White, here from Exertis Enterprise as the Intel Business Development Manager. First off, this is not my normal go-to, it's for November for a good cause, hence the very bad moustache. I'm actually 30, I know this looks like I'm 16, but please trust me on this. To my left we have Scott from Intel.
Hi, I'm Scott Pendrey. I'm one of the product specialists for our data center product line, and this is my normal get-up. It's not just for November.
So, thank you for joining us today in this lovely room. We're going to speak about all things Intel. First off, there's no secret that the boom word in the moment is all about AI. So, Intel and AI, how are they addressing this explosion?
So we've got a whole portfolio of different products that address AI, but I think one thing that's important is to take a step back first. You know, AI is one of these terms that's absolutely huge today. It's applied to almost everything.
Yeah.
You know, anything from autonomous driving, image manipulation, audio, all sorts. And I think it's important to break it down into more addressable targets, so that we can actually then get the right products to target each of those.
Yeah, I'm guessing when you talk about addressing, we'll talk about the brand new Sapphire Rapids AI accelerators.
Partly, yeah. So the CPU portfolio includes accelerators that will indeed accelerate AI workloads. But we have GPUs as well. We have dedicated AI accelerators as hardware over the top of the CPU portfolio. So a bit of everything. So the three key areas that we'll cover, but I think today we'll focus mostly on the CPU. Yeah. But yes, our AI accelerators are our Gaudi product line, and our GPU portfolio in itself breaks into really two key areas. GPU Flex, which is more for things like media transcode, online gaming, those kind of workloads. VDI, very big. And then we have our GPU Max portfolio. That's more the AI and HPC classic GPU product.
So if a customer comes forward with us AI, how would you differentiate if they need a GPU or the CPU with the built-in accelerators?
It kind of breaks down for me, and I'll probably simplify this far too much, but I think it really breaks down to complexity, and that in turn is things like model size, the volume of data that you're operating on, and of course the time you've got, the speed you intend to complete that compute task. So if we think about one of the really big AI workloads today is that people associate like ChatGPT, these sort of large language models. They can be huge. So multiple billions of parameters in those, especially the big ones that are encompassing all topics. So again, ChatGPT is a good example. If you're working on one of those, then you really need to have dedicated hardware that focuses purely on AI as the task, and specifically it's really about AI training. That's the hard bit. You've got to build the model to explain or to teach, if you like, the system how to respond. The actual inference then, so that is running that model and determining, how should I respond to this chatbot or whatever it might be. That's an easier task. It's not easy, but it's a lower level task, and so we tend to focus on training for GPU and AI accelerators, and inference, which is the actually using it. The CPU is great for that.
Yeah, perfect. So the GPU line, some people may or may not know about. Where can we source these GPUs? Obviously, they're a big player in the market at the moment.
They're available from the major OEMs. Not every OEM carries every model, so I can't be very specific, but you can access them from the major OEMs and from system integrators through yourselves. So
the 4th gen Sapphire Rapids have built-in accelerators and numerous ones. Can you briefly describe what they are?
Yeah, so there's really 4 optional accelerators, and then there's another 5th, if you like, which is very much targeted at that AI workload. So AMX is the one that's built into the CPU cores, present in all of the 4th gen Xeon product line. And that one is very much about AI inferencing and accelerating that particular task. The other 4 accelerators, all 3-letter acronyms. So Quick Assist, QAT, and there's IAA, DLB, DSA. So some of those are about streaming, analytics acceleration. So IAA is about in-memory analytics, and that really speeds up database applications, that kind of thing. DSA is all about accelerating data I/O and streaming. So there are four. I think it's more important really to focus on those that have a broader software adoption.
Yeah.
So the accelerators themselves are great, but you need the software which will then access that feature set. So Quick Assist has been around for a long time. It started as a add-in card, a PCIe add-in card. Then that feature moved into the chipset back in our Lewisburg chipset days. And now it's moved into the CPUs. And I again, just to qualify, it's not in every CPU. Each of them has a different configuration. So, but that's really, really good at things like compression, decompression, and encryption and decryption. Which in today's world, security through encryption is really important, and indeed compression is particularly important with big memory workloads and so on. So maybe things like AI with large models, but again it's more traditional workloads like databases and so on, really accelerated by QAT. IAA, as I said, in-memory analytics, again really focuses on the database market and really trying to accelerate things. SAP is a good example, but it also tends to be a relatively small deployment of those because it's such a big opportunity.
Yeah, they're obviously quite in depth. Just to let the guys know watching, we do actually have a white paper where we've broken down the 4th gen accelerators that if you contact the team, we're happy to share that, and it goes into a bit more depth, and we'd love to have a conversation about that with you. The AI accelerators, are they unique to Intel?
Well, all of them are.
Yeah.
So all four, QAT, IAA, DLB and so on, are unique to us. AMX is unique to us as well. It's arguably sort of an elevation built upon previous instruction sets that are included, things like AVX, AVX2, AVX 512. So it expands on that. But yes, all of those are unique to 4th gen Xeon, and will continue into 5th gen Xeon. And there's one other thing that I think is important to call out that is included as part of the Xeon product line, more generically, and that is VROC. So not an accelerator, but an opportunity to reduce the bill of materials, reduce complexity, and actually increase performance in certain situations. So, for example, VROC is all about adding in RAID capability directly on the CPU, on the chip. Yeah. Virtual RAID on chip, VROC. Now this is a really cool technology because you don't have to add in hardware RAID cards or HBAs to logically connect your NVMe SSD or SATA drives to that CPU.
And VROC is staying, because there was a time where unsure if it was staying or going.
Right, there was probably, I don't know, about 6 months ago, maybe a year ago, there was a question mark over it. It is absolutely staying. In fact, it gets some improvements in our next generation, which of course is 5th gen Xeon.
Yeah. Great leeway there. Next gen, I know some of it's still under top secret. What can you tell us about?
Well, so it's actually launching pretty soon. So mid-December, approximately is when we'll have the official launch of 5th gen Xeon. So I can't give you too much information around it because we're pre-launch. Certainly I can talk about the increased core count is fairly normal with most generations of CPU. So we'll increase up to 64 cores per socket, for example. We're increasing memory bandwidth and I/O bandwidth. But the other thing that's quite a more of a significant change is the last layer cache.
Okay.
So by growing that, we can again really target specific workloads, but AI is one that really does benefit from that larger last layer cache. As I said, coming in December, but it's really important to not consider that as a stop date on one and a start date on the next gen. You're going to see 4th and 5th in parallel moving through next year. And again, like 4th gen Xeon did this year, it launches, but then has to ramp into the market. Yeah. Typically in at the high end first, and then the lower core count and lower SKUs come through later.
Nice. So the future's exciting with Intel. So while we wait for the future, how would you summarise 4th gen?
Well, so 4th gen, it's here today. It's going to be here through next year as well. It's a excellent foundational building block for server systems, anything from 8 through to 56 cores. Not a lot of people really go to that high end. There's more of a sort of a mainstream sweet spot lower down in the core counts. So it's a fantastic product for mainstream and high end. There are some quirky SKUs for really extreme performance, things like Xeon Max family, which incorporates high bandwidth memory, built into the CPU. So that again is, targeting specific workloads. So I don't want to summarize as being, a general product. They're very tailored and very targeted for a lot of different workloads. And that's really the key is, we add accelerators in to target real world use cases, not just, a high performance benchmark specking and so on.
Perfect. I really appreciate your time today, Scott. I believe that's everything on the AI explosion. It's clear to see Intel's got an exciting future with their 4th and 5th gen coming out. Appreciate your time today.
It's a pleasure. I was going to ask you a question or two, if I may.
Of course.
So we're obviously a CPU manufacturer. We've been building and developing products for many, many years in cooperation with major OEMs and system integrators. How do you stand out from your competition?
Great question of why Exertis. 3 main points I want to point out here. State-of-the-art new integration facility opening up our current ones. It's going to be 3 times the size, so in terms of stock capabilities it's going to go up from around 300 pallets to 900 pallets. It's going to be a bigger workspace to integrate servers. Talking of servers, we've got our Flex server offering, which we've got server stock in-house built upon Intel 3rd gen, going to continue that onto 4th and 5th gen into the new year. That server is built out in about 14 days, stock dependent. And when we look at the market and the average is 8 weeks, we're way above the curve, and you get that fully built, configured, delivered server built upon Intel. And we've got a dedicated pre-sales team at our customers' disposal. 4 really good guys there with experience of almost 100 years in total. So yeah, we've got a really good pre-sales team, quick turnaround on servers, and a state-of-the-art integration facility that our customers can use and hold stock to cool off if needed.
Brilliant. Yeah, well, it's a pleasure to work with you.
Thank you, Scott. Guys, thank you for listening. Hope you found this as useful as I did. Obviously, sit alongside an industry expert. It's great to get his knowledge. As we discussed earlier, if you need any information on the 4th gen Xeon, we've got a white paper, we've got in-house experts. We can also team up with Scott to go through anything you've heard today or anything you want to know about all things Intel and Exertis. Thanks for listening.